Okay, hey, welcome back. This is 1.1 now, and introduction basically to graphing. And so, the first couple exercises in WebAssign or MyMathLab, I was just looking at. All they want you to do is plot points. I think most people have plotted points before. It seems simple. It was some other countries do it in different ways. That'd be interesting if you know anybody who's from a different country. Ask them. Is it any different? And it's kind of cool sometimes to take a check out one of their math books, and see what they're like. Like I have a friend who's from Russia, and he showed me one of his math books from high school, and they just used back in the day. They just had one basic book for the entire 4 years of high school, and everybody used that book. So it's different in different countries, and get out there, and meet somebody if you can. I know the pandemic and stuff. It's not like you're going to be running around. It's probably the last thing you want to do is be dealing with somebody from another country, but I don't know. Get pen pals. Do they still have pen pals? All right. So anyways, here's our Cartesian coordinate system. It's a way of sort of visualizing the solutions of equations, and it's divided into 4 quadrants. Okay, so in sort of like a counterclockwise way, you go 1, 2, 3, 4. Let's go ahead and plot some points in here. So usually in point plotting, this will be the x-axis or the first coordinate. This will be the y-axis, the second coordinate. And you put some tick marks on. Usually you assume you're going by ones, unless otherwise noted. So you put 2, 4, 6, 8, or whatever, but I'm going to go by ones. Okay. And typically I won't even bother writing in the numbers, but today I'll go ahead and so these negative direction here. Okay, and we want to plot some points. So, you ever played the game, it was a Battleship back in the day? Before it was electronic, you have to be able to do this. So you could play games and pretend you're doing math, okay, so point A, -1, means go to the left 1, and then up 2. So that's where A is. B, 0, 3. So don't move on the x-axis, but then go up 3. So here's B. Maybe use a different color or something. I don't know. C is 3, 0. So you go to the right 3, and then you don't move at all. So there's C. And then finally D, so go to the right 2 and then down 1. So there's D. Okay, so hopefully you've seen that before. If not, that's how you do it. Okay. Graphing equations are basically the solutions to the equations, the way of viewing your solutions. So solutions have kind of structures all to themselves. The first tried and true method is just plotting a bunch of points. Okay. And usually what you do is kind of make a table and then plot them all. So we wanted to work with this absolute value thing. And what is this? Well, we kind of know how it operates. So if you put in like -3, you get out 3. If you put in 2, you get out 2. Absolute value is super important in math. It has to do with distance, so very, very important. There's another way of defining it piecewise. Okay, so you could go -x if x is less than 0, and then x if x is greater than or equal to 0. Okay? So for example, if you have -5 in the absolute values, the way you evaluate it is because -5 is less than 0, you're going to write -5. Okay, so that's what that -x means in the first half of the piecewise definition. So -5 is 5. Okay, so there's no thinking involved. It's just a matter of substitution. Let's try -2. Right? -2 is less than 0, so I use this first part of the definition. Right? So I go -2. And of course, that's 2. And it follows along with the definition as you kind of already know it. Right? How about +3? Right? If I put in +3, now the x value is greater than or equal to 0. So I use this formula, x. So absolute value of 3 is just 3. Okay. So I just want to introduce that definition. It's used a lot later on, so but your intuition, as you already have it, is good too. That's fine. Okay, so what we want to do is evaluate. I don't know why I just did that whole sidetrack. I apologize, but like I said, it'll come up eventually if you keep taking math, and maybe even in this class. Okay, so anyways, let's get some points and plot the thing. So just picking some arbitrary points. The homework will give you some points, and then you'll put it into the function and evaluate it. So, okay. So -3 is 4. So I'm plugging these x values in here and evaluating. And you can do this in your head if you get good enough at it. That's fine. I don't mind. Absolute value 0 is just 0. 0 is not considered even negative or positive, believe it or not. Okay, it doesn't really have a sign. 0 is considered even, though. It's an even number, believe it or not. Okay, so we got our points, and then we can go over to our Cartesian coordinate system and plot these guys. And get an idea what the picture is. So even if you have no clue what the picture is, point plotting can point you in the right direction, right? So -3, 4, -2, 1, 2, 3, -1, 2, 0, 1. This little button on this pen I'm using, and it clicks like that, and it erases everything. Anyway, 0, 1, 1, 2, 2, 3, 3, 4. Okay, so it looks like a V shape, and there it is. Okay, so there's the graph. Using calculator as a graph, so calculator can do a table for you. If you have one of those TI calculators that kind of look like this, okay, and then you have all your buttons. There's a button like right up here and right here, and those give you the y equals, and then there's another one that says table on it. There's another one that says graph. Those buttons will allow you to make these tables, okay, if you want. So what am I talking about? I'm talking about using your calculator. If you keep taking math, you definitely want to get one of these nice TI graphing calculators. You won't really, I typically don't like students using them on tests, but for homework, yeah, you want to use it. It's like you have a microwave oven. Let's use the microwave. Let's not bother, building a fire in the backyard and, cooking things over the fire. It's going to take forever. Just use the calculator. Some things about using the calculator that you want to be aware of are the Xmax and the Xmins. So in your viewing window, this thing right here, your viewing window, It may look something like this. The X max is the right side. Okay. How far you go on the right. The X min is how far you go on the left. The Y max is the top, and then the Y min is the bottom. So in your calculator in that row of buttons right here, you're going to have something that allows you to adjust your viewing window. Okay, and it's going to ask you for X min and X max, and you can put in the appropriate values to position your window where you need it. And you take more and more math classes, and you get a better idea where you need to position that window. Okay. There's also these things called X scale, and those are what you're counting by on your tick marks. So usually I count by ones. So on that graph, I didn't write the 1, 2, 3 like this, but that's implied. I could have put 2, 4, 6 there, and that would have been scale. Okay, so this is just telling you kind of where your tick marks are. And there's also a Y scale as well, so you can have different X scales and Y scales. Okay. So there's the viewing window. I guess that's the first thing, and then there's also the table. So you should have a little table button in there, and what the table does is create this thing that we created back here, this T-table looking thing. Okay. And again, you should be able to adjust kind of where you start, where you end. So there'll be like a table start. All these calculators are different, so I'm not sure. It's table start, table, and then there might be a change in table, which usually tells you how you want to go. Like if it was like by 2s and your table start was 3, then when you go to your table, you're going to see your X values go 3, 5, 7, 9. So the change in table is telling you the difference between 2 consecutive values, right? So 5 minus 3 is 2, so change in table is 2. Okay, but like I said, all the calculators are different. You want to probably get a TI, because everybody gets the TI calculators, like a TI-84 is usually kind of typical. If you do opt for a better calculator like a TI-89, you probably don't want to get one with all the little apps on it. So they like have apps for practicing for your SAT and stuff. You don't need those. So just get a bare bones. I'd just get one on eBay. You can probably find somebody who's trying to, is never going to take math again, who's just trying to get rid of their calculator. And on eBay, they'll try to overcharge you too. So they try to find somebody who doesn't know anything. I think my calculator was 100, but I got like a TI 89. So, buyer beware. Okay, so anyways, let's go back to doing these things by hand. So in addition to tables, a quicker way maybe is just looking at the intercepts. So this is a quick way to kind of get some of the information about the graph. So the intercepts. So first off, the x-intercept, and then secondly, the y-intercept, right? The x-intercept is where y is equal to 0. So it's an ordered pair where you have some a and then y is 0. The y-intercept is where the x is 0. So you have 0 and then maybe some b. Visually, we can draw a picture here, maybe some weird polynomial thing. Right. So the x-intercepts are the places where it hits the x-axis. So we have a guy there, 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 there. The y-intercepts are going to be the places where it hits the y-axis. Okay, so in this case, there's just one y-intercept, which is there. And it's a y-intercept and an x-intercept. Okay. Let's look at an example. These examples are just equations of lines. So we have a line going through these 2 points. Let me make sure I'm recording. Hello? Yeah, okay. Sorry. Every once in a while I gotta make sure I'm recording. It's nothing worse than when you screw up a video. Okay, so lines going through these points. And the question is, what is the x-intercept? What is the y-intercept? Okay. Usually I write them as ordered pairs. So the x-intercept, it's always y is 0, and the y-intercept, the x is always 0. Or sorry, vice versa. Like that. Okay, so the x-intercept clearly is at 1, okay, and then the y-intercept is clearly at 2. Okay, that's kind of simple. Let's maybe look at what they have in the old web homework problems. So here's number 20. The table of values was generated by the graphing utility with a table feature. Use the table to determine where the points determine the points where the graph of y1 and y2 intersect. So you could just go through the table and find where y1 and y2 are the same. Okay, so it looks like at 0 and at 1. So there's more than one answer. 0 and then 1. Hopefully I don't get these wrong. I have not practiced today, so that's not correct. Whether they want ordered pairs. Oh yeah, they want ordered pairs. So great. Type ordered pairs. I need the redirections, don't I? So it's at 0, 3, and then comma, what's the other one? 1, 4. 4. Yay. Let's see what else they got. This is one like we just did. Determine the x-intercepts if there is one. You can zoom in on the graph using this button. You can make the graph pop out using that button. So the x-intercept looks like it's 1, 2, 0. Okay. Camera. I don't know if they want you to rate it as an ordered pair or just write the number. They just want an integer. Okay, so you just write 2. Okay, you don't write 2, 0. Let's see what else. The y-intercept is at 0, 1, 2, 3. So we can just write 3 for them. That's all they want. Excellent. Oh, what's this thing? It's just finding intercepts again. And what's this guy? Intercepts. Here's a story problem. Let's try this. The graph shows percentage of high school seniors who used alcohol and marijuana during the 30 days prior to being surveyed. The data can be described with the following mathematical models, where n is the number of years after 1980, a is the percentage of seniors using alcohol, m is the percentage of seniors using marijuana. Use the appropriate line graph to determine the percent of seniors using marijuana in 2009. So we can pop out this thing and look at it. 2009 is right here. Looks like the marijuana one is the purple one. So it looks like it's at 30. Okay, so 30%. Okay, thank you. 30. Use the appropriate formula to determine the percentage of seniors who use. Okay, so they're comparing and contrasting the actual data with the formula that kind of predicts the data. Okay, so the formula that's predicting the percentage of marijuana use is m equals negative 0.5 n plus 35, and n represents the number of years after 1980. So if you're talking about 2009, you're going to go 2009 minus 1980, so that's 29 years, and that's our n value. Okay, so the percentage of marijuana users would be negative 0.5 times 29 plus 35, and I'm going to need my calculator. So Calcutron. Calc. And so what do we have? negative. Oh, I could use a stupid negative symbol. It's clear, clear, clear. 0.5 negative times 29 plus 35. 20.5%. They want an integer or a decimal, so 20.5. It seems way off. So, where's my submit button? Check answer. Okay, great. Determine the formula underestimates or overestimates. So it's way under, right? 20.5 is less than the actual value, 30. So it's way under. And to find out how much under it is, you just subtract the 2. So let's say it's 9.5%. Okay. And then they just want you to do the same thing with alcohol. So let's go ahead and skip that. Oh, more story problems. Let's see if there's anything in the beginning that is. So just doing a table of values. Table of values. Table of values. So a bunch of that stuff. Graphing ordered pairs. So plot negative 4, 4. So negative 4. 1, 2, 3. Whoops. 1, 2, 3, 4. Oh, negative 4. Negative 4, negative 4. So there. That's pretty easy. Okay, so we'll let you go there. It's usually if you got any problems, come in my office hours, and I'll see you when I see you. Okay.